There's a better way to do this, right? To get to the problem, as you can see, we start with the problem with we have we don't know how many nickels, how many pennies we need, but when we add up the coins, they should add up to $8.80. And the only clue that we have is that the number of nickels is always twice as many as the pennies. So that means we have 10 nickels, then we'll have how many pennies? Oh, listen carefully. If I have 10 nickels, how many pennies am I going to have? Five. You see that? I'm asking it backwards, but you got to understand the relationship between pennies and nickels. So, just like in the other problem, you notice that we have two things to deal with: nickels and pennies. We don't know the exact number of nickels or pennies, so the first thing that we should do is to declare. I'm like, okay, I have for nickels, I'm just going to declare it as a number of nickels, N for nickels, okay. And for P, I'm going to use P for pennies, and this is represent a number of pennies. Okay. All right. I don't know how many number of nickels I have. I don't know how many numbers of pennies I have. But the only thing I know, like I said, is that for the number of nickels, it's always twice as many as the pennies. You see it? This is how we got our first equation. It's very basic, and you can actually test out this too to see if it works. Let's say I have 5 pennies, then 5 times 2 is 10 nickels. It works, right? So we know we verified that this equation is legit. It's good to go. And the second equation we need is actually the dollar amount of the number of pennies and the number of nickels. We also know that for each nickel, it is worth 5 cents, 0.05, and for each penny, it is worth 1 cent. Okay? So we use that information. We know that, hey, if I say, Zukwi, if I give you 20 nickels, how much is that? $1. How did you get that amount? If it's 20 nickels, how do you know it's $1?
Because
you times it by what? How do you know that 20 nickels worth $1?
Times by you.
Okay, so you basically take the number of nickels, right?
Yeah.
Times it by how much it's worth, each nickel, which is
5 cents.
5 cents. And so you take 20 nickels times 0.05, you get $1, right? So that's how we do. So to get the dollar amount, we take the amounts worth per nickel times the number of nickel, right there. You see that? That'll give you the dollar amount for the number of nickels, which we don't know at this point. And also, we also know that for pennies, it's 1 cent each. And I don't know how many number of pennies I need either. However, when I add these two amounts together, the problem tells us that it should equal to what? $8.80. $8.80. Now, for those of you who do not like to deal with decimals, did we learn a way to clear our decimals already?
Yes.
We look at the longest place value, right? In this case, they're all 2 places over, which is what place value? 100. So that means if we want to clear the decimals, all you have to do is just take the whole thing, times it by 100. And you times it by 100, guess what's going to happen? This becomes 5n, this becomes 1p, and this becomes 880. See it? So now my decimals are gone, and I'm good to go. So just go ahead and erase that equation out of your memory so you have to deal with it again. You know, you don't want to deal with it. There it is. So now, next step. This is the crucial step, as you can see, that we know that this involves 2 variables, and we do not know to solve 2 variables at the same time. The only thing that we know is to solve for 1 variable at one time, right? Last time we learned the process of elimination. But this time, if you notice and look carefully, that this says n is equal to 2p. n is 2p. That means 2p is n. Is that true? That means every time we see an n, we can also replace the n with 2p. So 2p is like another name for n. If you have a nickname, for example, you have a nickname, man? Who has a nickname in this class? Yeah, Tino. Huh? Tino, right? So that means if I call him Tino, he would just know that it's him without having to call directly Santino. Is that true? So here, it's the same thing. 2p is n, so that means I don't have to say n. If I say 2p, you know it's n. So that means if you look at this right here, that every time you see an n, I can replace that n with 2p. That process right there, when you replacing, is called substitution. Why am I substituting? Because when I substitute, this is the end result that you will see. I'm substituting, and do you notice that your variable now will come down to just one variable? It's p. And we know how to combine like terms. Versus the previous case, we can't combine like terms. Not yet, right? But now when we start substituting, we can say, oh yeah, because n is 2p, I substituted, then I can just go ahead and multiply this out. What is 5 times 2p? 10p. So it's going to be 10p plus 1p equals to 880, and we know very well that 10p plus 1p is 11p. So I'm just going to go and write it over here. 11p equals to 880 divided by 11 both sides. P is 80. And then if you say, wait, what is P again? All you have to do is just go back to the very top of the problem. And you said P represents the number of pennies, so 80 represents how many pennies? 80 pennies. And we know the relationship of nickels to pennies, right? Relationship is nickels is always twice as many as pennies. So if the pennies is 80, right here, then how many nickels will I have? 160. And that's how we solve our problem. 80 pennies, 160 nickels, and of course, if you test it out, 160 times the worth, the dollar amount for nickels is exactly $8, and 80 pennies added to $8 is $8.80. Any question on this one? Okay, so you see how it works, right? So I'm going to pause this here, and I'll show you. Actually, I'm not going to pause it, but I'm going to show you the graphing approach as well. And you will be doing this tomorrow using GeoGebra, okay, in your group. So let's go ahead and change a little bit. So because GeoGebra only works with x and y, then we have to change the variable a little bit. Let's define our nickels to be x and our y to be our pennies. I want you to make sure you remember that, right? So when you change that, this will become x equals to 2y, right? Is that true? And for this one right here, this will become what? 10x? No, sorry. 5x plus y equals to 880, right? So these are the two equations I'm going to graph. And let's graph these two right now. Let's take a look at your GeoGebra right here. First equation, remind me again, please. What is it? X equals to 2y. So I'm just going to quickly show you here that I did indeed enter x equals to 2y. I hit enter. Next, what's my next equation? 5x plus y equals to 880, right? Remember, we converted back. That's why we tossed it. Okay, so that's it. So I look at this right here. Let me move it over. Notice I have two lines, two linear lines, and there is an intersection. I'm going to go ahead and find an intersection by clicking intersect two objects. Hit right there where the intersection occurs, and look at this right here. We declare x to be nickels. We declare y to be pennies, and we got exactly 160 and 80. So what does that mean about the intersections of the two lines? What are you finding when the two lines intersect? You're what? What is this? What does this represent? Is that your solution to the problem? And so imagine if you don't have an intersection, then you have a solution. What do you think? What if the two lines never intersect? What does that mean? What can you conclude? That will you have a solution at all? Then no. Certain problems won't have a solutions, right? And you understand that too. So don't expect to have a solution all the time. Sometimes it just simply won't work. And therefore, we won't have a solution. But in this case, if you expect to have a solution, then you should see an intersection. If the two lines don't intersect, we don't have solutions. So kind of keep that in check as well. And by the way, when will we have a no solution case? What will happen? What will the line will have? What do the two lines will have to look like in order for you to have a no solution case? Parallel line. Okay. Any questions so far? All right.